In-class activity 12A, the Montreal Tower. The Olympic Stadium, built for the 1976 Olympics in Montreal, Canada, features the world's tallest inclined tower. Visitors may ride a glass-enclosed funicular along the outside edge of the tower to an observation deck at the top. The tower is inclined at an angle of 45 degrees, a far greater tilt than the Leaning Tower of Pisa, which leans about 4 degrees. From a point 425 meters from the center of the base of the tower, the angle of inclination to the center of the observation deck is 35 degrees. See the diagram. And I'm just going to scroll here, and we are going to extend the page. There's the diagram, part 1. Without doing any calculations, devise a strategy for determining the height h of the observation deck above the ground. Well, one thing that you could say is, we could say, since two angles of this triangle are known, the third can be determined. The third angle also, since one side length is known, the law of sines can help determine either of the other two sides. The definition of the sine function can now be used to find h by focusing on the small right triangle on the right side of the diagram. Let me just scroll up a little bit more, and we can put that information here as well. And I'll put since one side length is known, the law of sines can help us determine either of the other two sides. And definition of sine function can now be used for h. And we'd find h by focusing on the small right triangle on the right side of the diagram. Let's go on to screen 2. Objectives for the activity. You will understand that the law of sines may be used to solve oblique triangles in which two angles and one side are known. You will be able to solve oblique triangles in which two angles and one side are known. Next screen, preview assignment 12A, introduce the law of sines, which we see here. A simplified version of the diagram on the previous page is shown. That goes back 2 screens. And here's our triangle again. Part 2, it says, let the sides and angles of the triangle from question 1 be labeled as in the diagram shown. The following steps can be used to determine the height of the Montreal Tower. Part A says, first, find angle B. Let me scroll up a little bit here. Well, that's going to be pretty easy. We know that we can start with 180 degrees, and we see that angle C is 45 degrees. We can subtract that out, and we can subtract angle A, which is 35 degrees. And when we do the subtraction, we get 100 degrees. And that's our angle B. Let's go on to the next screen. It says part B, use the law of sines to find side A. Well, the law of sines we can write as A over sine of A equals B over sine B. And we don't know what A is, but we do know the sine of A. It's going to be the sine of 35 that we're going to use because angle A is 35 degrees, and that's going to be equal to B, which is 425. And I'm just getting these numbers off of the diagram from the previous screen. And then sine of 100 degrees. I'm going to rewrite this so that it is solved for A, or A is written in terms of everything else. So we get 425 times the sine of 35 degrees. And that is all over the sine of 100 degrees. All right, when we do this calculation, we find that A is equal to about 247.5 meters. All right, let's go to the next screen. Part C, it says use right triangle or right angle trigonometry to find the height H. Refer to the diagram shown. So here's our diagram again, and we want to find the height, that dotted line, H. So what we could do, let me just scroll up a bit. I know that we have this angle C, which is 45 degrees. We can write the sine of 45 degrees is equal to H over. We found A on the previous screen to be 247.5. And if we rewrite this, we're going to write it as H is equal to 247.5 times the sine of 45 degrees. And we find this when we do the calculation, we get 175, and that's in meters. Okay. Next screen. On 3, it says, suppose that in triangle ABC, B is 110 degrees, C is 25 degrees, and side C is 5 degrees. Find the remaining sides and angle by answering parts A and B. Part A says sketch a triangle and label the angles and sides. Okay, so we can do that. Let's start with a triangle. There we go. Just going to call that angle A, angle B, and angle C. So this would be side A, this would be side B, and side C. B is, what is it, 110? So this is 110 degrees. C is 25 degrees. Put 25 degrees in there. And side C is 5 feet. So I'll put 5 next to the side C. Okay. Part B says find the missing sides and angle. Find side B before finding side A. Okay. So one thing that we could do is, we know angle B and we know the measure of angle C. So we could find angle A pretty quickly by subtracting these values from 180 minus 25 degrees. And that's going to be what? That's 45 degrees. And that's our angle A. So there's part of it. We have 2 more things to find. We have to find side B and side A. So we're going to need the law of sines here. So if I want to find side B's length, we can use the law of sines in this form. And then I don't know B, so I'll just use B again. And then the sine of B is the sine of 110 degrees. C is length 5. Sine of C is now sine of 25 degrees. Rearrange this so that B is written in terms of everything else, and we get what? 5 times the sine of 110 degrees over the sine of 25 degrees. So we find out here, once we Do the calculation, we get about 11.1, and that's going to be in feet. One thing left to find is side A's length. I'm going to use the law of sines again, and this time we're going to take A over sine A, and then the same thing on the right side, C over sine C. A can stay A. The sine of A becomes the sine of 45 degrees. And then C is 5 over the sine of C, which is the sine of 25 again. So rearrange this. A equals 5 times the sine of 45 degrees over the sine of 25 degrees. All right, calculating this, we get A is about 8.4 feet. And that's the end of this video. Thank you.